Imagine building a chat app where messages arrive instantly, or a stock ticker that updates without refresh. Traditional HTTP's request-response model struggles here. That's where WebSockets shine, offering a persistent, two-way communication channel. Traditional HTTP is a stateless request-response protocol. To get real-time updates, clients constantly poll the server, asking any updates. This creates significant overhead with every request needing new TCP handshakes and HTTP headers, even when there's no new data. WebSockets, however, establish a single, long-lived connection, dramatically reducing this wasted effort. The WebSocket journey begins with a standard HTTP GET request, but with a crucial upgrade header, signaling the client's intent to switch protocols. The server, if it supports WebSockets, responds with a 101 switching protocol status. This isn't a redirect. It's an agreement to upgrade the existing TCP connection to the WebSocket protocol. Once upgraded, HTTP is out of the picture and a full duplex channel is ready for data exchange. The benefits are profound. Full duplex communication allows simultaneous sending and receiving. This single, persistent TCP connection dramatically reduces network overhead, leading to much lower latency and more efficient resource use, crucial for high-frequency data updates. It's a game-changer for responsive web applications. On the client side, typically in JavaScript, the WebSocket API makes establishing a connection straightforward. You provide the WS // or WSS // URL, then define event handlers for connection open, receiving message S, and handling error S or close events. Sending data is as simple as calling ws.send with your payload. Server-side implementation varies by language and framework, but the core logic is consistent. Using a library like Python's WebSockets, you listen for new connections, register them, and then handle incoming messages. The server can then process these messages and broadcast updates to all relevant connected clients, demonstrating its ability to push data proactively. Once the handshake is complete, the WebSocket connection operates as a free-flowing conduit. When client A sends a message, the WebSocket server receives it, potentially persists it to a database, and then immediately pushes that update to all other subscribed clients, like client B, without them needing to request it. This reactive, server-initiated push is what makes real-time possible. WebSockets power the instant messaging in your chat apps, the real-time updates in online games, and the lightning-fast stock tickers on financial platforms. Any application demanding immediate, continuous data exchange, from collaborative editing to live IoT dashboards, finds its core strength and efficiency in WebSockets. WebSockets transform the web from a series of disjointed requests into a fluid, real-time data stream. If you found this useful, hit like and subscribe for more deep dives into system design and software engineering.